Hi everybody, I want to go over 3 more problems. One of these is from your worksheet, so this problem right here is problem 5 from side A. These are 2 new problems which aren't on your worksheet, which by no means maybe you don't want to do them, but I think it will help you figure out fractions, negative exponents, and then just this quotient property. What do we do when we have the same variable with powers in the numerator and the denominator? So let's take a look. We remember this property that says when we have a fraction raised to a power, so like 4/3 raised to the negative 3, that you can kind of apply that power down to both the 4 and the 3. So 4 to the negative 3 and 3 to the negative 3. Now we know that the negative exponent property takes something from the numerator and puts it in the denominator, and takes something from the denominator and puts it in the numerator. And then all you do is change those powers to be positive. So we would have 3 cubed over 4 cubed. So when you have a fraction raised to a negative exponent, you can think about it this way, that the negative exponent takes the fraction and produces its reciprocal, 3/4, and then we still have that positive version of the power, a positive 3. That's going to give us the same answer here, but it's going to save us this awkward step of writing a numerator with a negative power and a denominator with a negative power. All right, I've talked about this before, but I want to look at these 2 problems, one kind of simple, one a little bit harder, to explain what we do when we have a quotient, when we have the same base in the numerator and in the denominator with powers. So the rule is that you take the numerator's power minus the denominator's power, and that is your answer. So x to the negative 8th. The negative exponent property tells us that that is 1 over x to the 8th. Now there's a simpler way to do this. It takes a little getting used to, but I think it's really helpful when you get into it. So what you do is you look at the numerator's power and you look at the denominator's power. Of course, the base needs to be the same. So this wouldn't work if I was working with x to the negative 3 and y to the 5th. It's got to be the same base. You look at those powers and you say, which one of those powers is bigger? So the denominator has a bigger power. 5 is a bigger number, and I mean more positive than negative 3. And then you say, how much bigger is it? Well, 5 is 8 bigger than negative 3. So your answer is going to be in the denominator, because the denominator had the bigger power, and it's going to be 1 over x to the 8th, because those numbers are 8 apart. All right, another example of this. Remember, when we have x's over x's and y's over y's, we can think of this as 2 separate problems. So remember that the quotient property we worked on tells us that you just subtract the power, denominator power from the numerator power. When you have all positives and when the numerator is bigger, it works really well. So we kind of thinking the way we did in the last problem, we could say which number is bigger, 10 or 3? 10 is bigger. And how much bigger? It is 7 bigger. So we're going to have in the numerator x to the 7th. Looking at the y's, we have y to the negative 4th over y to the 6th. Which number is bigger? 6, the number in the denominator. And how much bigger? It is 10 bigger. So in the denominator, we are going to write y to the 10th. And the normal way to write this answer is x to the 7th over y to the 10th. All right, so I'm going to give you 2 more problems that I want you to try and figure out. You can pause the video and work on them. Try x to the 5th times y to the 6th over x to the 7th times y to the 11th. And try y to the negative 3rd over y to the 12th. All right, now would be a good time to pause the video. All right, here come the answers. The answer to the one on the left is 1 over x squared times y to the 5th. And the answer to the one on the right is 1 over y to the 15th.